You have finished easy. You named simple steps in plain English. Now the problem gets a layer deeper, but the method stays exactly same. A medium problem looks more complex, but it isn't. It's just a simple problem with one more extra observation hidden inside. So we have to name the pattern, speak the steps, and then translate it. The pattern can change, but the method never changes. So we'll try to solve few of the problems. Here, the problem is to find the two numbers in a list that adds up to a specific target value and return their position. Here we can see the example. We have got input a list of numbers where we have 2, 7, 11, and 15, and the target is 9. Here the output is position 0 and 1 because the position 0th element, which is 2, and position 1th element, which is 7, sums up to the target, which is 9. Now, before we move on to the logic, I want you all to pause this video here and try to make your own logic in your notepad or notebook. Write it down and then try to see if you're able to make it. And if you're not, then which steps you have lagged. So the step one, we have to, for each number, we will subtract it from the target and it will be the missing piece. So the missing piece which we have got after subtracting the number from the target, we will check if this is already in the list which we have. And if we found that number, then we can return the position of both numbers and this will be the output. For the first element, which is 2, if we'll subtract it from target, we will get 7. And if we'll look again into the list, we can find the 7 as the first index. So in this case, yes, we have found the pair and we can return both the positions. In a scenario where we are not able to find the number, then we can remember the current number and move on. And this steps we have to repeat until the pair is found. The next problem is to return a new list that contains each element only once with no repeating values, which is removing the duplicates. Here we can see the example. We have got a input of list which consists of multiple numbers and few of the numbers are repeated too, and the output is a list which is having the unique number out of this. So here I want you all to pause the video and try to make your own logic and verify it whether you are able to make it or not. So let's move forward and see the logical steps. So first of all, we have to create a empty list, which we can name as unique. And what we'll do, we'll look at the first item in the original list, which we have got as input. And we have to check, is it already in the unique list? If it is, then we will skip to the next number. And if the number is not in the unique list, then we will add it to the unique list. And these steps is what we have to repeat for every item in the original list. And at the end, the unique list will contain all the unique numbers from the input list. And this is very easy. Let's move to the next problem. Here the problem is to find the number that is strictly smaller than the maximum but larger than all the rest, which is the second largest. So here we'll see the example. Here we have got the input as a list of numbers. And here we see the maximum is 8 and the second maximum is 6. Now I want you all to pause the video here and write your own logic and then verify it with our logic. So the first step is we have to track two placeholder. One is the champion and another is the runner-up. Means one will be the maximum and second will be the second highest or the second largest. So the second step is we have to look at the each number in the list, and we have to check if the number is bigger than the champion. If it is, then the champion will become the runner-up and the new number will become the champion. And if it's not bigger than the champion but bigger than the runner-up, then that number will become the runner-up. And these steps is what we have to repeat until the list ends. And at the end, the runner-up is the answer, which is the second largest. Now, the next problem is factorial. So factorial is we have to multiply a number by every positive integer below it, all the way down up to 1. Here we'll see the example of factorial 5. So for factorial 5, we have to multiply 5 with all the numbers which is less than it up till 1. So we'll multiply 5 by 4, then by 3, then by 2, and at the end by 1. So the output which we have got is 120. And similarly, if you'll see for factorial 4, we have repeated the same. We have multiplied 4 with 3, then with 2, and then with 1. And at the end, we have got 24. Now, here I want you all to pause the video and try to write your own logic and verify it with our logic which we are going to see forward. So the step 1 is starting a running total of 1. Then take the target number which is n. Then multiply the running total by n and subtract 1 from the n. And repeat these steps 3 and 4 until n reaches to 1. And at the end, you will have the factorial of that number. Now we have the problem Fibonacci series. Here the goal is to generate a sequence where each number is the sum of the two numbers directly before it. Let's see the example. So the first 7 terms of a Fibonacci series looks like this. The first number is 0, then next is 1, then the next number, which is the third number, it will be 1, which is the sum of previous two numbers. And similarly, as we'll move forward, it will keep increasing as the next number will be the sum of the previous two numbers. So after 1, we'll see 2, and after 2, we'll see 3, then 5, then 8. And here you can see the logic, it is written there. Now pause the video, write your own logic, and verify it whether you're able to write it or you require some clarity. Step 1 is to start with two numbers, which is 0 and 1, which we have to take initially. The next number, which will be the sum of the last two numbers. So the next number, we will take a variable, or we can sum the previous two numbers to get the next number. So in step 1, the next number will be 0 plus 1, which is 1, which is the third number. So we can see the new list, which is having the three numbers of the Fibonacci sequence. And similarly, when we'll move forward, then we have to sum the last two numbers, which is 1 and 1, and we'll get 2. And this we have to follow, keep adding until the last two numbers reaches the desired length. And this is very easy. You just have to take the previous two numbers, sum it, and you will get the next number. And then you have to repeat for the next number. You have to take the last previous two numbers from that number, and you'll get the next number. And this you have to repeat until the desired length of the Fibonacci sequence is reached. Now, here we have the problem of prime number check. We have to determine if a number is only divisible by 1 or itself. Here we can see the example of the prime number 7. We have seen is a prime number because there is no divisor for 7. And 9 is not a prime number because it's divisible by 3. Now I want you all to pause the video and try to write your own logic. So step 1 will be if the number is 1 or less, then it's not a prime number. Then try dividing by every integer from up towards. Does it divide with no remainder? Not. Then if it does, then it's not prime and we have to stop and reach the number itself with no clean divisible, then it is prime. So here there is one tip which I'll ask you all to follow, that we only need to test up to the square root of the number because that's the maximum number, highest number which can divide a number. So we'll take the square root, we'll start from 2 and we will go up to till the square root of the number and try dividing it, dividing the number with all the elements, all the numbers up till the root of the number from 2. And if it gets divided with no remainder, then it means it's not a prime number. And if it does not get a cleaner division, means if it gets divided for each of them with a remainder, then it is a prime number. The next problem is valid anagram. So anagram is, we have to check if two words contains the exact same letters in the exact same quantities. Here we can see the example, which is listen versus silent. So listen and silent both contains the similar alphabets with similar quantities, so it's an anagram. Whereas hello and world are not anagrams because they both have different letters and in different quantities. Pause the video here, write your own logic, and then verify. First of all, we'll have to check if the two words have different lengths. And if they have different lengths, then it means they are not having similar quantity of alphabets. So it means that they are not anagram. So we can verify it here, and if they're not having the similar length, we'll stop here and we'll give that it's not an anagram and we'll stop here itself. In case the counts matches, then count how many times each letter appears in word 1. Next step, we'll have to count how many times each letter appears in the word 2. And then we have to compare the two counts letter by letter. In case of listen and silent, we'll see L comes only once in word 1, and similarly it comes once in word 2. And for all the other alphabets also, it's similar. In step 5, we have to check every count matches exactly for each alphabet, then they are anagrams. The next problem is title case. Here we have to capitalize the first letter of every word in a given sequence. Here we can see the example where we have got the input string as thinking beyond code, where every word thinking beyond encode in the input is the first letter is in small case. Now we have to capitalize the every first letter of each word. In the output we can see the thinking beyond code, every first letter of each word have become uppercase, which is capitalized. Now pause the video here and try to think the logic and verify with the logic we are going to see further. The step 1 is to split the sentence into individual words, and this we can do by splitting it by the space. Step 2 is for each word make its first letter uppercase, which we can access easily. Now force all the other letters in the word to lowercase. And in the next step, resemble the words back into the sequence with spaces, and you'll get the output of a string where each word have a first letter as capital. Now, the next problem is list intersection. Here the goal is to find all elements that appear in the both of two separate lists. It's like finding the common. Here we can see the example where we have list 1 and there we have list 2, and if we'll see the intersection of both this list, we have got 3 and 4 because in the list 1, 3 and 4 is there, and in the list 2, 3 and 4 is there. So these are two common numbers or the elements which are there in both of the lists. Now pause the video here, try to write your own logic and verify it with the logic we are going to see further. So the step 1 is to take the first element from list A. Search through all the elements of list B, and we have to check does it appear there. If it is in the list B, then add it to a new shared list. And then we have to move to the next item in the list A and repeat the same step. Step 2, we have to search it again in the list B, and if it appears, we'll add it to the shared list. And at the end, the shared list is the intersection of both the list. Now, the next problem is we have to rotate our list. Here the goal is to shift every element in a list to the right by position k positions. Element at the end wrap to the front. So it's like a cycle or a circular where the last element will come into the front, and we'll see how we are going to do that. First, we'll see the example. Here we have got the input list, which is numbers from 1 till 5, and we have to shift this to right by 2 positions. So here if we'll see the output, we can see the 2 position is shifted to the right and 4 and 5 have wrapped and came into the front, and 1 is shifted to the third position because we have shifted the 2 positions. And this is a cyclical list, or we can say circular, where the previous last element will come into front if it's going over the length of the list. Now pause this video here, try to write your own logic and verify it further with the logic we're going to see. First of all, we have to identify how many steps or case steps we need to rotate the list. Then we have to pick the very last item in the list and then move it to the very front. Shift all other items one position to the right, and this we have to repeat until we reach exactly k times. So we have to take the k, let's suppose it's 2 in this case, and we have to take the last element and we have to put it in front, and we have to keep repeating it k times. At the end, we'll get the resultant list, which will be the shifted list by the k positions. So the problem here is missing number. We have to find the one missing integer in an array that should contain every number from 1 to n. Let's see the example. Here we have input which is 1, 2, 4 and 5, and it should have to be from 1 to 5. And here we will use the formula to check the sum of a series from 1 to n, which is n into n plus 1 divided by 2. So according to it, here the number of elements is we have to have 5 numbers. So we will multiply n into n plus 1, which is 6, and divided by 2. So we will get the 15, which is the expected sum of all the numbers from 1 to 5. And here we see the expected sum is 15, but the actual sum of the current list is 12. So the output is 3, which is 15 minus 12, which is the number which is missing from the given list. Now pause this video here, try to write your own logic and try to verify whether you are able to write it. Step 1 is to calculate the expected total sum using the formula which is written here, n into n plus 1 divided by 2. Step 2 is add all the numbers exact that are actually present in the list and subtract the actual sum from the expected sum. And the difference is the exactly number, which is the missing number. So this is very easy. You can try to do this. And there is one more way which you can do. You can create one more list where you have all the numbers and you can check which number is missing out of both. Next problem is Word frequencies. Here the goal is to count exactly how many times each unique word appears in a block of text. Let's see the example. Here the input is the cat sat on the mat, and output is frequency of the is 2, cat is 1, sat is 1, on is 1, and mat is 2. So here we have find the frequency of unique word in the given string or the given block of text. Now pause the video here, try to write your own logic and verify it with the logics we are going to see further. So step 1 is to create an empty ledger which will be of type dictionary to track the word counts. Read the first words from the text, and if we want to get one word out of a sentence, then we can split the sentence by spaces. Then we have to check, is that word is already in the ledger in the dictionary? If it is, then add 1 to its count. The word is not in the ledger, then we have to write into the ledger with a count 1. And we have to repeat these steps for every word in the text. And at the end, in the ledger, we will have all the frequencies of the word. The next problem is binary search. Here, the goal is to rapidly find a target value in a sorted list by repeatedly halving the search space. Let's see the example. Here we have to find the 23 in a given list, which is the numbers 1, 5, 10, 15, 23, 40, and 55. So first of all, we will find the mid of the list, which is 15, and which is too small from the 23. So we have to look at the right side of the list because it's a sorted list. And in the right side, the next half of the list, we'll see again the mid, and we'll see the 40, which is again too big from the 43. And if it's too big, then we'll look at the left. And at the left, once we look, we'll found 23, which is the number we are trying to search. And this is called binary search because we try to half the given list every time using the same logic. We try to half and look at the number, look at the mid of the number. If it's too high, then we'll look at the left, and if it's too small, then we look at the right side. Pause this here and try to write your own logic and verify it with the logic we are going to see further. So the step 1 is that list should be sorted. This is the first, you can say the prerequisite, that list must be sorted. The next step is look at exact middle item. So how you can find the middle? It's easy. You can find the length of the list and divide by the 2. You will get the mid of the list. Next step is it your target? The number which is in the mid of the list, is it your target? If it's not, then we can move further. And if it is, then we already find the number. Now, if the target is smaller, then ignore the entire right half. And if the target is larger, then ignore the entire left half and keep repeating this until you find the target. The next problem is bubble sort. So here goal is to sort a list in ascending order by repeatedly swapping adjacent elements that are in the wrong order. So we have to sort a list using a bubble sort algorithm. Now we will look at the example. Here we have a list which is 5381. So in the first iteration or the past one, we have sorted 3, 5, 1, and 8. So 8 bubbles to top. Then in the past two, the 5 moves to right, and in the past 3, we have got a sorted list. Now pause this here and try to write your own logic and verify. So step 1 is to compare the first two adjacent elements or the items and check if the left item is bigger, then swap it and move one step right and compare the next pair. And continue this to the end. The largest item bubbles to the top, and repeat full passes until 0 swaps occur in the full pass. The next problem is the longest word. We have to find the longest word which is having the most characters in a given sentence. Here we can see the example. It is having an input string which is I love writing clean code. Here we will first try to check the length of each word. So length of I is 1, love is 4, writing is 7, clean is 5, and code is 4. So the output is writing because it's having the 7 letters or 7 characters. Pause this video here, try to write your own logic and verify. Step 1 is to split the sentence into individual words using the space. Then assume that first word is the longest. Look at the next word and count its characters. And if that word is longer than the current longest, then we will update the current longest to the current word and repeat this until all the words are checked. And at the end, we'll have the word which is having the most number of characters. So medium problems looks harder because the pattern is less obvious, but the method is identical. Once you can name the pattern, it is just easy with one more step. Name the pattern, speak each step, the code writes itself.